My name's Steve Wicks and I look after the data centre practice here at MTI.
Hi Steve, so Sam Spence, I work for VMware in our networking and security business unit.
Paul Kennard, Senior Consultant, Extrovert.
What we're here to discuss today is our experiences with clients as they work through their data centre modernisation. And a lot of our clients are looking at the difference perhaps between running a traditional server and SAN-based storage, which they might have been using for a number of years, and what the advantages are of going for something like a hyper-converged solution. With hyper-converged, what we find our clients are really liking is the virtual technology you get within a software defined data center. So with hyper-converged, you have the vSAN, or VMware Virtual SAN, and they see that as an excellent way of enabling their environments to be scalable and easy to adopt new challenges as they arise. But the next thing they're looking at doing is, okay, so we've looked at the storage and we've managed to get that into a software defined angle. But what's the next thing to do regarding security would be to have a look at the network, and perhaps we can look at a software-defined network strategy as well. And that's really where we're starting to have a lot more interest from our clients. What I thought I'd do today is really get your experience and your feelings for how that is working in the bigger client picture that you see out there in the big world. So for example, a lot of our clients are moving towards 100% virtualization to aid them in their ease of, if you like, transacting between a public cloud and a private cloud. So looking at that area in some detail. But I think traditionally what we're finding is within the modernisation of a data centre, the aspects around security are becoming far more important than they were before. So I think if we could kick off with that really, about our clients, how they can increase the security of their new environment if they're looking towards a hyper-converged solution. That'd be really helpful. So I guess the main issues they have is the more virtualized they get, the easier it might be to go, if you have a virtual machine that gets compromised, to try and restrict it so that it can't then infect, if you like, other machines within that virtual environment. So I'm wondering where software-defined networking can help us with that particular aspect of a virtualized environment.
Sure.
Who would like to take that challenge on?
So my take on it is, lots of our customers and organisations out there have been virtualising the compute stack for a vast number of years, probably 10 to 15 years, if not longer. And latterly, as you point out, storage has gone through that same virtualisation transformational journey, probably in the last 3 to 5 to 6 years. And layers 2 through 7 are really the next evolution of that. And whilst virtualisation of compute brought with it the sprawl and the growth of that environment from the physical boxes that we had to many hundreds of virtual machines, with that sprawl and with that growth and proliferation of virtual machines, the underlying networking and security elements that are tied to those workloads are inherently more difficult to manage, more complex, and operational overhead. And by taking layers 2 through 7, so switching and routing and the security portfolio as well through the same level of evolution in terms of virtualization, we're able to apply a similar or the same operational model that we do for the VM and for the storage, but now for the routing, for the switching, for the firewalling, the load balancing, etc. So yeah, it's really an operational efficiency to be able to do that in software as opposed to in a serial manual process in a hardware.
No, I think that'd be very helpful though. It's certainly a challenge, which quite often, because of the experience of virtualization, it's very easy to spin up a virtual machine. It's also very easy to perhaps not have the right network activity or network restriction, as I say, applied to that virtual machine. So anything that we could do to simplify that process is definitely going to be taken as a step forward with our clients. I don't know whether you've got any particular examples you can think of where that's been, that's the one main reason for introducing virtualized network is specifically to lock the machines down and prevent them from communicating with each other.
The key sort of function, feature of NSX is microsegmentation. Obviously, gives you the ability to isolate that VM straight out the door. And able to actually secure it from the get-go if you're using stuff like dynamic security groups. Lock it down, based on tags, groupings, server names, host names. You're able to, really just from day one, of deployment of VM, have a system secured from the get-go. And microsegmentation is often the key feature that NSX is sold on, but that's just one small piece of the pie, really.
So what is it? You can explain a bit more about microsegmentation and what it actually means for a bit more of a layman's terms. That would be very helpful.
Okay. Microsegmentation is really just the ability to the VMs are protected individually rather than traditionally you would have your firewalls from the and access control lists that would govern what's allowed, what's not. From the VMware perspective, you've obviously got the firewall that's built into NSX, and the VMs, rather than secured, actually individually on their own. And the firewall is managed from a central point on the NSX manager. So it's a lot less management around the actual firewall perspective, and also allows you to the actual firewall itself can actually the policies and stuff can move across the site. They move with the VM. So the VMs are very much a lot more agile when it comes to actually the workloads moving. The actual security moves with that VM.
Because that's really important, because I know back in the day when I used to dabble with ESX service audit and used to set things up, it was quite straightforward to build the virtual machine, but you're absolutely right, sometimes when it was migrated from one ESX host to another, it would lose connectivity, and that was always a bit of a battle to work out where to point the finger. Is it something wrong with the configuration? Invariably it was the network configuration hadn't been set out equally across all the machines. So I'm hoping this is going to be a thing of the past.
I think it takes the legacy approach that Paul describes, where we essentially use VLANs and create access control lists, and you put security policies on the end of VLANs and a number of virtual machines on each VLAN, and you typically hairpin that out to the edge through a physical firewall. Once you get such a vast number of virtual machines, it becomes unmanageable to have the same number of VLANs. So to be able to tie a security policy to a workload, have it be born with the workload, have it move and live with the workload, and have it die with the workload. This mantra of tying security policies to workloads as opposed to tying workloads to VLANs, which have control lists on them.
That's a much more sophisticated way of doing things, really.
So
you would create a policy to begin with, and then you would actually attach your virtual machines to a policy rather than the traditional VLAN approach evolved.
Yeah, I mean, you could have a VM that just has a tag assigned to it. So upon deployment, that tag is dynamically added to the security policy. So as it hits the ground, it goes straight into that and is secured from the get-go. So it's one of the major benefits, I'd say.
That sounds excellent. So I guess one of the issues again is with, for example, a lot of public-facing IP addresses, is you might end up with a lot of DMZs for keeping the access restricted from the public to the input. So I'm wondering if I did have a lot of web servers that have their own individual DMZs, obviously it's the best way of dividing things up in the olden ways of doing things. What's the best way of doing this with the new sort of software-defined approach with NSX?
So I mean, one of the sub-uses of the broad term security inside NSX would be DMZ anywhere. So that is the mantra of collapsing down that what is a physical, isolated, air-gapped infrastructure, which is a safe haven and typically a landing place for things like contractors and third parties and all sorts of people like that. The mantra is to collapse the infrastructure down, which is typically vastly underutilised and thus very expensive. We collapse that down into the core stack, and we create the same level of isolation, but rather than doing it physically with air gaps and in siloed infrastructure, we do that logically inside NSX. So we're able to apply those security policies in our hypervisor. We apply our policies in filters that we have in between the virtual machine and the virtual distributed switch. It's quite unique for VMware in that we own the hypervisor, the ability to place these security policies on the workloads virtually, so we can create the same DMZs, the same sort of safe havens, the same sort of areas of security for third parties and contractors to land. But now, as opposed to them being air gapped on the side of the infrastructure and a silo, they're now incorporated into the core stack.
And this is okay as far as the CISOs you just had discussions with. They're okay with not having the physical air-gapped environment any longer. They're happy to let ESX, if you like, and NSX handle that segregation.
Yeah, so I'd say, and Paul, you can probably elaborate on this, but I think it's evolving quite quickly. Like with anything, when you transform something or do something radically new, there's resistance, particularly from an audit and a governance perspective. We had that with VLANs. We had that even with virtualization many years ago, going from physical to virtual. And then when we started creating segregation inside the data center with VLANs, that was controversial at the time. So it's a journey, it's evolution, but I'd say we're making good strides in that, and more organisations are seeing the benefits of collapsing the DMZ down. Because not only do they still get the same level of security which they can manage better, they also bolster their core infrastructure stack, because they can suddenly fold down additional hosts, different firewalls, additional switches, more capacity essentially that goes back into the core stack and gives them more resources for the server workloads, for example.
I guess that would be another question really, because you rightly said you're consolidating an awful lot of external hardware into the ESX cluster. So I'm just wondering, does that have any impact on performance or maybe latency? As a result of not having physical devices doing that work?
No, I mean the actual the edge service gateways and the NSX components really don't have a lot of overhead, to be honest. And I mean, I think the key benefits of such as a collapsed DMZ as outweighs having the traditional way, because I mean obviously the traditional format is obviously again through access control lists. Once the if it's a denial of service, for example, once it's in the DMZ, it could potentially focus its attacks on all of the web servers. But if you're using something such as NSX, even once it's in, you can segregate. So you say web server 1 should never talk to web server 2, should only talk to app 1 and DB 1. Yeah. So you can basically again isolate your workloads so that even if there was something compromised within the DMZ, the actual impact would be limited down to what you're even allowing to talk within there. That's where traditionally it would potentially be able to affect the whole network.
Yeah, and I think the other point as well is we move from a centralised model to a distributed model, whereby now we hairpin out through a physical firewall that's centralised for everything, and it's at the edge of the network. We now distribute firewalls or other kernel modules in the hypervisor at line rate across a number of hosts. So the scale is linear. As you add host, you add bandwidth. So there's that to consider as well.
It does make sense, doesn't it? Because obviously when you're building out your ESX cluster, you're building it so it can scale out, and now you're basically given it the advantage. Now you can scale your network out at the same rate. So it does make sense.
Organisations now have employees using a variety of different devices. It's now commonplace that they use them anywhere they like, they use them when they want, how they want, etc. Sometimes they're corporate devices, sometimes they're personal devices. What the VMware message really from a networking and security point of view is the virtual cloud network. So it's not just the data center security product, it's not just an edge network product, it's a suite of products which spans 4 or 5 products, NSX being the sort of the one that underpins all of them.
Sure.
And that stretches right from the edge of the network, the mobile devices, right into the data center, out to the WAN, to remote sites. So all those endpoints can be secured and integrated with some of our mobile device management technologies like Workspace ONE, for example. So there's integrations between Workspace ONE and NSX to secure right out to the edge of the network. Not just the remote site, the WAN network, but also the access layer out into the edge and out into the device.
So it does sound we've got most of our options covered then in terms of right from the edge right into the data center. Something else that would be, I think, of great interest is a lot of our clients, not only do they have production workloads running within their data center, they're going to have test and dev and so forth. And when a lot of people want to create their test and dev, they want to be as near to production that they're going to be importing, if you like, into their test and dev environments. So quite often people will be taking clones of their running virtual machines, for example, and then big issue about that, of course, is if you spin up a clone, you've got to go and then fiddle with the IP addresses to make sure you don't clash with the production. And quite often what people really love to do would be to have a whole set of virtual machines that actually form the application suite, which they can then stamp out separate copies on and run multiple different patching, testing and so forth. Is that something that we can use the VMware portfolio to enhance? I'm thinking really about the difficulty of changing an IP address, because it quite often will break the application because it doesn't expect that. So what can we do around that, do you think?
I mean, utilising the NAT features within NSX will give you the ability to, have overlapping IPs. And obviously, if you team that with something like VRA, then you can blueprint out your environments for test dev.
Oh, that sounds perfect.
Just cookie cut them and just to bring up and destroy it. And again,
that sounds like that's very, very helpful, because that's really is a big issue for a lot of people.
And I'd agree. We see the use case quite common. It's quite commonplace for organisations to use NSX and a cloud management tool like a vRealize to create versions of test and dev, and the overlapping IP addresses, they can increase the rate at which they do test and dev. So not only does it create more speed in that process, but it also allows the networking community and the test and dev community to coexist, and it also encourages the test and dev community, who typically are potentially potentially siloed, working away from the rest of the team, and sometimes don't necessarily consider networking and security in the way they should. It allows them to apply networking and security policies, via API calls, in code, with agility, essentially, which is the reason why they shy away from it, because it's currently slow and manual. So.
Exactly. I think ideally, if we can do it in a blueprinted fashion, as you described, it's going to be more reliable, easier to do it more frequently. So all that can really help with is enhancing the speed to get to the end goal of that patch is now good to release.
Get
on with the next one.
And that's the beauty of putting the networking and the security elements into software as well, because lots of our customers out there, lots of organisations will have an automation workflow for the creation of compute and the allocation of storage policies, and that's kind of where right now we finish.
Exactly.
And it often gets thrown across the fence into the networking and security team, and maybe it comes out the other side 3 or 4 weeks later with IP addresses and with security policies and load balancers attached, etc. So if we're able to blueprint the whole workflow of application creation, not just compute and storage, but also layers 2 through 7, suddenly our automation journey becomes a whole lot more compelling.
Absolutely. And the more value we can get out of the automation, the easier it is to justify the extra costs and so forth. It should make things much simpler. So we've now got our primary data center secured, and we've automated the creation of our policies around security. We've done our test and dev creation and automation, again, with the vRealize. The next step, if you like, which doesn't have to be in this order, but a lot of people are looking to introduce disaster recovery, whether that's in a secondary site or whether perhaps we can enhance that still further by a stretch cluster, because that means we can move workloads seamlessly backwards and forwards between the two sites. Clearly, the thing that stops that happening mostly is IP changes, network changes, and so forth. So can that again be enhanced with NSX?
Yeah, absolutely. And basically what we're able to do is stretch a layer 2 broadcast domain across multiple sites, multiple vCenters. And what that allows organisations to do is create layer 2 adjacency across site without needing to either stretch the layer 2 network physically, which is a kind of a networking no-no, and creates quite a large blast zone, creates spanning tree and all sorts of problems, and not really best practice to stretch layer 2 physically. The other option, as you point out, is re-IP addressing, which is a real headache. So being able to stretch our layer 2 network over a layer 3 underlay is a really unique thing for NSX, and it manifests itself in a few ways. It can revolutionise DR, so it allows the failover process from an active to a passive, or from a primary to a secondary site a lot more straightforward. You don't need to necessarily mess around with the firewall rule policies. There's no re-IP addressing to do. Equally, the same technology allows you to create active-active data centers, where most of our customers historically have operated an active-passive scenario. There's an appetite to move towards active-active and actually start to use both sets of those infrastructures, as opposed to have one almost sat there dormant for the 5% of the time. Organisations now want to use both of those all of the time. So the problem with running apps in both places is the networking and the IP addressing, and now that problem's kind of no longer there with something like an NSX product in place.
If you utilise something like vSAN and SRM, it really gives you the ability to have the mobility you never had before, and simply just by mapping the networks within SRM that you've created already in NSX, you can fail over to the other site and have that one-click DR solution that you didn't have previously before, so you can run out of business, run out their building with the others. If a disaster should happen.
I guess one of the things that I get asked all the time is, we want fully automated DR. And I've always said, no, you don't. Because what is your definition of when the disaster happens? You really need an intelligent person to make that decision. And hopefully, with the simplicity of it is a single button to press. You start failing over and bring machines up in the correct order for the remote site. Then that kind of, that's going to make things so much easier. I still think, and this is what I always tell my clients, you don't want to make it fully automated. Because there might be a situation, it's a temporary one, it's a few minutes.
Yeah, you may just need to fail over one application.
Exactly.
So if you can set that up within SRM so that you just fail over a part of the business, it's not a complete DR situation. You can just take over that piece, and it continues running as is. So
glad we're all on the same page.
It's a flexible VR.
Yeah, I think, and I think that there's, NSX and SRM do dovetail nicely. Where SRM orchestrates the graceful failover, if you will, and brings the second site up in the correct order, as you point out, it doesn't necessarily handle things like the need to re-IP address the workloads, or all the security policies that are tied to the workloads, the access control lists that are on the firewalls, etc. So being able to do both those things in tandem, DR can be streamlined by sort of 60-70%.
That sounds really good. And I guess leading on from that is, I'm thinking the scenarios we just described were perfect if you've got two data centres, but maybe you haven't. So maybe you've got your private data centre and you want to now have a hybrid environment where you've got a private cloud linking into the public cloud. Hopefully you'll be able to help me out with that issue as well, really sort of securing those connections and making things hopefully as seamless with the public cloud as it is with having your own environment. Will that be the case?
Yeah, absolutely. I mean, ultimately what you're talking about is DC pooling, so whether that's an on-premise data centre in your office space, whether that's a co-location facility from a third party, or whether that's a public cloud, be that natively or something like, I think one of the topics you're going to talk about later is VMC on AWS. So whether we're talking about native public cloud, something like Azure or AWS themselves, or whether we're talking about a VMware stack running in their data centre locations, the mantra is still the same. It's a stretch of a layer 2 broadcast domain across multiple sites. So that brings in hosters, it brings in tertiary sites, it brings in clouds.
Excellent. So it does sound like we've got our options open there. We don't have to have our own data centre. We can make use of public cloud. Sounds like we've been very interesting discussion this afternoon. And thank you very much for joining us both today. It's been a pleasure meeting you both, and hopefully we'll carry on with more discussions. Thanks very much.